Good morning, students. In previous class, we were discussing about the properties of amines. Yes, we have discussed physical properties, and then followed by we started chemical properties too. Okay? So among those chemical properties, we were talking about the basic nature of amines. Basic nature of ammonia. We have compared ammonia with amines. We have compared amines primary, secondary, and tertiary. We even compared the basic nature of alkyl amines with what? Aryl amines too. And also, we also come across what the basic nature of substituted aromatic amines means about aniline, substituted aniline. What happens if electron donating group is attached? What happens if electron withdrawing group is attached? So we have already come across those things. So basic nature, as I said, we have discussed about basic nature, but in gaseous state. So till now we have discussed about what the basic nature of amines in what gaseous state. Right? So now today we are supposed to talk about the basic nature of amines in aqueous solution or in aqueous state. Okay, so let's start the basic nature of amines in aqueous solution. Basic nature of amines. Basic nature of amines in aqueous solution. Aqueous solution. Basic nature of amines in aqueous solution means in presence of water, you can say. Okay, so in gaseous solution or in gaseous state, we know that tertiary amine is more basic than secondary and followed by primary. But however, in aqueous state, unexpectedly, tertiary amine is least basic in nature. Clear? Tertiary amine is what? Least basic in nature in case of what? Aqueous solution. The basic nature of amines in aqueous solution has different order. The basicity order is different compared with what? The basic nature of amines in gaseous solution. So that can be explained based on two factors. The basic nature of amines in aqueous solution can be explained based on what? Two factors or two effects, you can say. One is steric effect, another one is solvation effect. One is what? Steric effect, another one is solvation effect. So before going to that, I said the order of amines in aqueous solution is different compared to what in gaseous. So order is secondary. Here comes secondary. R2NH is more basic in secondary. Then I'm having primary, tertiary in fact, tertiary, and I'm having primary, and I'm having what? Primary. R and H. Secondary, tertiary, and primary. So this is the order of basic nature. This is the order of what? Basic nature. Okay. So this is the order of basic nature of amines in aqueous solution. This is except for methyl, not for methyl. For any other alkyl group, R might be any other alkyl group except methyl. Please remember, this is not for methyl, except methyl amines. For methyl amine, it is of different. Okay. For example, C2H5 taken twice NH is more basic, secondary is more basic than C2H5 taken thrice N. Tertiary is more basic than primary, that is C2H5 and H2. So this order, this is the order which I have written. So ethyl amines follow this order in aqueous solution, not tertiary, secondary, and primary as of what gaseous state. In aqueous state, there is a change. We'll discuss why. And if I'm talking about the methyl amines, there is a change in what methyl. In case of methyl amine, CH3 twice NH. Here I won't get tertiary, I'll get primary CH3 NH2, and least is CH3 thrice N. Tertiary, primary, and secondary. Okay. So this is the basic order that we are having for what? Methylamines. Methylamines, ethylamine. For all alkyl it is same except what methyl. For methyl it is secondary, primary, and followed by tertiary. Okay. Please note on this. These are the order of basic nature of alkylamines except methyl. Secondary, tertiary, primary, and for methylamine we have a separate order, that is secondary, primary, tertiary. So we will discuss why it is so in case of what? In case of what? In case of aqueous solution. In case of gaseous solution, we usually explain based on what? Inductive effect. We usually explain based on what? Inductive effect. But in case of aqueous solution, we got two more effects. One is steric effect and the one is solvation effect. So let us talk about those two effects. Let us learn in details about what? The basic nature of amines in aqueous states. So when they are dissolved in water, what happens? When amines are dissolved, when amines are made to dissolve in water, what happens? See, donation of electron is nothing but formation of hydrogen bond with water. Because see, I am having two effects. I said this can be explained based on what? Two effects. One is steric effect. One is what? Steric effect. Steric effect. Another one is solvation effect. Another one is what? Solvation effect. So these two effects, based on these two concepts, we can explain the basic nature of amines in what? Aqueous solution. Why it varies from what gaseous state. So let us talk about steric effect. So what do you mean by steric effects? What do you mean by steric effect? Steric effect is something depends on the size of alkyl group. It depends on the size of the alkyl group. For example, in case of primary amine, there is only one alkyl group. In case of primary amine, I am having only one alkyl group. In case of secondary, I am having two alkyl groups. And in case of tertiary, I am having three alkyl groups. Okay. So the size of alkyl group is greater in comparison with what? Hydrogen. So that may not allow an incoming molecule, so it can form a hydrogen bond. Because remember, I am talking about the basic nature of amines in aqueous solution. Means RNH2 amines in aqueous solution, in the sense they should dissolve in not water. They should dissolve in water. So they are going to form RNH3 plus OH minus. So now this guy is going to form hydrogen bond. And so as to form hydrogen bond, it has to come and attack with nitrogen. Or these hydrogen should form what? Hydrogen bond with water molecules. Then they are dissolved in water. So that might be avoided because of bulkier, because of presence of what? Bulkier. So in primary I am having only one bulkier group. In secondary I am having two. In tertiary I am having what? Three. So tertiary is having more steric effect. It is sterically hindered more. So attack of an water molecule is not allowed because of bulkier group, because of presence of bulkier group. So this is nothing but steric hindrance or steric effect. So attack of a molecule is avoided by the presence of bulkier groups. That is nothing but my steric effect, steric factor. So according to steric factor, there is a steric hindrance in tertiary. The more steric hindrance in tertiary, in fact, compared to what secondary and followed by primary. So according to steric effect, tertiary is what? Least basic. Tertiary is what? Least basic than secondary. Secondary is more basic than primary. Means order is tertiary is least, then followed by secondary, then followed by primary. So this is according to what? Steric effect. Steric effect is nothing but presence of bulkier group not allows an incoming molecule to come and attack because of presence of bulkier group. That is nothing but steric effect, and steric effect is observed more in case of tertiary, less in case of primary. Here, tertiary followed by secondary and followed by primary. Primary is less sterically hindered. So I can say it can form faster hydrogen bonds. I can say it can donate faster. I can say it is going to be a strong base compared to what tertiary in case of aqueous according to what Steric effects. Yeah, according to Steric effect. So this is the concept Steric effect. This is the first concept based on Steric effect we can explain. So according to this, you just remember tertiary, secondary, and primary. And now let me talk about the solvation effect too. Then what this solvation effect explains. So what this solvation effect gives idea of. So let us say solvation effect is nothing but when an amine is dissolved in water. When an amine is what? Dissolved in water. For example, I am having primary amine. Primary amine is made to react with water plus H2O. Clear? So this guy is going to form R NH3 plus OH minus. Here, secondary amine. I am having secondary amine. R2 is that R2 NH is going to react with what? H2. So as to form R2 NH2 plus OH minus. Okay, so there are lone pair of electrons, and those lone pair of electrons are donated to this one. It's sulfuric acid reacting as a acid. It donates proton. The proton is accepted by this nitrogen, so as to form this selenium ion. So if suppose these are stable, like earlier, like in the previous class we have discussed, if a compound will after donation is going to attain stability, then it's more basic things. Similar, right? If these bands are going to attain stability, then these amines are more basic. So let me write the third one, that is my R3 and also made to react with water so as to get R3 NH plus OH minus. So solvation effect, when they are dissolved in water, I can write these things. Or else these can be written like this. RNH3 plus can form 3 hydrogen bonds. It can form hydrogen bonds with 3 moles of water. For example, RNH3 plus can be written as RNH3 and H3 plus. This hydrogen can form a bond with what? Water molecule. One of the water molecule. So this hydrogen can also form a bond with another water molecule. Okay. So this hydrogen can also form a bond with another water molecule. Okay. So this can form 3 hydrogen bonds. So let us go for this one now. R. This can be written as R2NH2. R2NH2. This R2 can be written as, so this R2 is nothing but RR, right? So nothing but R2 and H. So here there are 2 hydrogens, so it can form 2 hydrogen bonds or can bind it with what? 2 water molecules. 2 water molecules. Here it can bind with what? 3 water molecules. Let us go for the third one, R3NH. There is only one hydrogen, so this can be written R3 N plus H. Here I am having positive charge. Here also having positive charge. Here also I am having positive charge. So there is a hydrogen. So now there is only one water molecule can bind in case of what? Touch. So there will be an energy when something is dissolved in water. If any element is dissolved in water, the amount of energy released is called as hydration energy. So greater the tendency to form hydrogen bond, greater will be its hydration energy. So hydration energy is more in case of what? Primary amine, as it can bind, a tendency of formation of hydrogen bond is more. So more hydration. Here I am having what? More hydration in case of what? In case of primary. As we move down, what happens? There is a less hydration. There is a less hydration. Okay? So there is a less hydration. So I can say tertiary do not have more tendency to form what hydrogen bond. Secondary has a bit more compared to tertiary, but primary has even more tendency to form what hydrogen bond. So this guy is forming 3 hydrogen bonds. Means this guy is more stable compared to these 2. This is least stable among these. If it is least stable, then it is least basic. Clear? So solution effect is nothing but when an amine is dissolved in water, it is going to form hydrogen bond so as to attain what? Stability. If compound after formation is going to attain stability, then the reactor goes what? More basic in nature. So according to solvation effect also, as we move on, you can see hydration goes on decreases. Hydration is maximum for what? Primary. So primary has more tendency to form on hydrogen bond because I'm talking about aqueous solution when it is dissolved in water. So according to this also, I got to know that tertiary is least than secondary and followed by primary. Clear? So by using these two effects I have explained till now, and in both the cases I got to know that the order is to your tertiary, secondary, primary. Primary is more basic than secondary and followed by tertiary. So it is exactly opposite to that of according to what? Inductive effect. According to inductive effect, the order is tertiary is more greater than secondary followed by primary. But according to these two effects, tertiary is least compared to what? Secondary followed by primary. So this is exactly opposite for the order based on what? Inductive effects. Clear? As a combined effect of all these, in case of aqueous solution, as a combined effect of solvation effect, as a combined effect of steric effect, as a combined effect of inductive effect. Combined effect of all these, the order changes. Order changes so as to give you secondary. Secondary will be more basic. I'll rub all these things. So, as a combined effect of all these, steric factor, solvation effect, inductive effect, everything we are supposed to look after. Here, as a combined effect of this one more is what? Inductive. As a combined effect of all these 3, at last we got that secondary amines are more basic in nature than followed by tertiary and followed by primary. Where R is what? Ethyl and so on. Ethyl, propyl, methyl and so on. Not methyl, except what? Except methyl. Except methyl, not for methyl. So what happens in case of methyl? Methyl is smaller alkyl group among all. So compared with ethyl, propyl, butyl, methyl will have a less steric hindrance. Or steric hindrance is less in case of methyl. So that is why for methyl we got secondary, primary and tertiary. This is the order for what? Methyl amines. Methyl amines. Order for methyl means CH3 taken twice, NH is greater than CH3, NH2 greater than CH3 taken twice, N. This is the for methylamines. And for ethylamine, I can write over here. For ethylamine, please note down C2H5 taken twice, NH is greater than C2H5 taken twice, and then C2H5 NH2. So this is for ethylamines. This is for what? Ethylamines. And this is for what? Methylamines. So order of basic nature of methylamine in aqueous, ethylamine in aqueous. So there is a change for methylamine because methyl is sterically less tender, or it is not that heavier or bulkier thing. Methyl is smaller, so steric hindrance will be less. So that is there is a small change over here. Or else, if it is replaced by C2H5 or C3H7 or bulkier groups, if methyl is replaced by, if suppose there is a change in upside group, there will be a change in what order of basic nature for alkyl. So this is for all alkyls except methyl, and this is for okay. So this is the basic nature of what amines. Basic nature of amines in what aqueous solution. Okay. So that's it. This is about the basic nature as well. And after this, we need to go for some reactions shown by what amines. First one is reaction of amines with what acids. So let us go for that. I'll drop this. So the reaction of amines with acids. Reaction of amines with acids. Here it's the basic nature. So next, chemical property is reaction with acids. That is nothing but the proof for it is acting as what base. It is acting as what base. Clear? So we are supposed to discuss about what the reaction with acids. Reaction with acids. Reaction of amines with what? Acid. Reaction of amines with what? Acids. Okay. For example, I am having trimer R and H2. I will add HCl. So primary amine is made to react with what? HCl or HS. In general, I am talking and right. I am written general, so I will take an halogen acid HS. Can you please tell me what you can expect? You people know that amines are what? Basic in nature. Clear? Amines are basic in nature because they don't have electron. So they are reacting with acid. They are going to form R. NH2 will become NH3 plus X minus. NH3 plus X minus. Means alkyl ammonium halide. Alkyl ammonium halide. They are going to form alkyl ammonium halide. They are going to form salts with acids. Here, I will write an example for this one. I am having methylamine CH3 and H2 is made to react with HCl. By saying that general example, can you write the product? So this is going to become what? CH3 NH2 will become NH3 plus Cl minus. Yes, sir. What would be the name? Methyl ammonium chloride. Which alkyl I am having? Methyl. Methyl ammonium chloride. Methyl ammonium chloride. So this is an example in which amine is made to react with acid. Similarly, if suppose this guy is going to react CH3 and H2 with what you can say HNO3, nitric acid, another acid, HNO3. What you would have got? You tell me. CH3, same. CH3 and H2 will become what? NH3 plus NO3 minus. Means methyl ammonium what? Nitrate. Methyl ammonium nitrate. Clear? So I am going to get methyl ammonium nitrate. If this methyl amine is going to react with what? HNO3. Methyl amine is going to react with what? HNO3 so as to give you what? Methyl ammonium nitrate. Clear? For example, I am having Aniline is aniline. I'm having NH2. Now NH2 is made to react with HCl. What happens? NH2 is made to react with HCl. What happens? You tell me. Yes, what you can read? Same benzene ring. NH2 becomes NH3 plus Cl minus. Means anilinium hydrogen chloride. Anilinium what? Hydrogen chloride. Aniline hydrochloride you can say. Or anilinium chloride. So I can say anilinium hydrogen chloride. Anilinium chloride in fact. Anilinium chloride or aniline chloride. Sorry, anilinium hydrogen chloride. Anilinium hydrogen chloride or aniline chloride. Aniline chloride is also correct. Anilinium hydrogen chloride. So this is how amines are going to react with what? Acids. These are going to react with what? Acids. So it shows their basic nature. It shows their what? Basic nature. So they are going to form salts, ammonium salts. They are going to form alkyl ammonium salts. They are going to form salts. That's it. Okay. So this is the first in which amines are made to react with acids. Then we got second reaction. Reaction of amines with alkyl halides. Reaction of amines with what? Alkyl halides. So I'll rub these examples, these reactions. Now I need to talk about the reaction of amines. Reaction with whom? With whom I said? Yes, with alkyl halide. With what? Alkyl halide. That is nothing but addition of alkyl. So alkylation of the amines. Let me talk about the alkylation of amines. Yeah. Alkylation of amines. RNH2. I will write over here. RNH2 is made to react with RX. Can you please tell me what happens when amines are made to react with? This one. I am having a primary amine. Primary amine is made to react with what? Is made to react with alkyl. RR will become R2 NH2 plus X minus. R2 NH2 plus X minus. Clear? To this one I will add a base. To this one what? I will add a base. So what I am going to let you tell me? I am going to add, after addition of base, this HX will come out. HX will come out. If HX is coming out, what I will be left with, tell me? R2 NH. So I have converted primary amine into what? Secondary. Even secondary amine can also be converted into what? Tertiary, by adding one more mole of alkyl. I can even convert tertiary amines to what? Quaternary ammonium salts again by adding one more mole of alkyl. So addition of alkyl group is nothing but alkylation. Similarly, so what happens? I will write directly this time. I will skip this step. R2 and H, I am adding Rx. What I am going to get? I am going to get R3 N. Because there will be minus HX. R3 N. I am having tertiary. Again, I am going to add one more mole of Rx. At last, I am going to get R4 N plus. I am going to get quaternary ammonium salt. R4 N plus X minus quaternary ammonium salt. So I am adding alkyl, excess alkyl. So addition of excess alkyl by using alkyl halide is called as what? Exhaustive alkylation. Exhaustive alkylation or methylation. I am adding methyl over here. Exhaustive alkylation. It is called as what? So addition of alkyl group till you get quaternary ammonium salt from primary. For example, I am having CH3 and H2. To this one, I will add CH3Cl. I will write direct this product. What I am going to get, you tell me? I am going to get CH3 taken twice NH. Again, I will add one more mole of CH3 here. In all the cases, HCl is removed. Here again, HCl is removed. Then tell me what I will be left with. I will be left with CH3 thrice N. Tertiary. Again, I will add one more mole of CH3Cl. CH3Cl. So again, I am going to get CH3 taken 4 times plus Cl minus. So this is my quaternary ammonium salt. So I have converted a primary amine into what? Quaternary ammonium salt. So conversion of primary amine into quaternary ammonium salt by addition of excess alkyl groups, by addition of excess alkyl halides is called as what? Exhaustic alkylation. Exhaustic alkylation. Okay. For example, I will take an aromatic amine this time. I am having an aromatic amine that is nothing but my NH2 aniline. To this aniline, I will add methyl iodide CH3I. CH3I. What happens when the hydrogen is replaced by what? Methyl group. So I am going to get NHCH3. NHCH3. Again, I will add one more mole of CH3I. I will add one more mole of CH3I. What I am going to get, you tell me? I am going to get NHCH3 CH3. Clear? Primary, secondary, tertiary. Right? Sorry. There will be no hydrogen over here. Tertiary. And if suppose again I am going to add one more mole of one more mole of methyl iodide. Again I am going to get a quaternary aluminum salt or ammonium salt. I am having CH3 plus Amines. So again I have converted primary into what? Quaternary ammonium salt. So this conversion from primary to quaternary ammonium salt by addition of excess alkyl is nothing but my exhaustic alkylation. So this is the alkylation of amines. Amines can be alkylated by adding what? Alkyl halides. Okay? So on addition of alkyl halide, primary is converted into secondary. So this is the intermediate. I have done only over here. Everywhere I have skipped this one. This is the intermediate. After this one, after adding base, there will be a formation of secondary. Same thing over here. And here I have skipped that step and have written on the direct reaction, direct products over here. Okay? So this is how amines reacts with what? Alkyl halides. Okay? So now let us go for the next concept. So after alkylation, I will go for acylation. After alkylation, I will go for what? Acylation. So let's talk about acylation now. Let me talk about acylation. And for alkylation, I have added alkyl halide, and for acylation, I am supposed to add acyl halide. That's it. Reaction is for acyl group. Acyl halide, which is acyl group. RCO. This is acyl. Addition of this group is what? Acylation. So I am talking about the acylation of amines. I am talking about acylation of amines. So let's say I am having RNH2. RNH2 is going to react with the CH3COCl. It's going to react with what? CH3COCl. CH3COCl. I'll write this as CH3COCl. Or is better. Don't make confusion for you because I'll write CH3COCl. CH3COCl. Aside. Clear? So these lone pair of electrons will come and attack over here. Then these electrons are transferred to oxygen. So what I am going to be telling, I will be left with CH3, CO minus Cl, and here I am having what? And there are two hydrogens and there is an alkyl group over here. So hence there is a positive charge. Clear? So these electrons will come back and form a double bond. This chlorine will go along with one of the hydrogen. This hydrogen go along with the chlorine. HCl will be removed. Please remember what I have removed. I have removed HCl. Then will you please write the product? Yes. This is CH3. CH3. C double bond O. C double bond O. Yes. Cl not. So I am having N. There is only one hydrogen now. NHR. So CH3CO NHR. Correct, no? This is the right product. Yes or no? See what happens. These don't electrons are going to attend this carbon, and there will be a transfer of pi electrons. I am going to get this compound. Again, those electrons will come back and chlorine will go because halogens are better relating. Halogen will go along with this hydrogen. The electrons of this hydrogen will be given back to what? Nitrogen, so as to satisfy this positive charge. At last, I will be left with CH3 C double bond O, CH3 CO, NHR, CH3 CO NHR. That is nothing but my amine. I am going to get an amine. Amine is prepared. So when amines are made to react with acyl halide, acylation, when they undergo acylation, they are going to form amine. I'll take a particular example now. Imagine I'm having what C2 CH3NH2. I'm having same what CH3NH2 or earlier C2H5 NH2. C2H5 NH2. I will add CH3COCl. Directly write the product. What you are going to get. What you are going to get. On the hydrogen will go along with the chlorine minus HCl. Minus HCl means I will be left with what? CH3CO. CH3CO. Hydrogen bond out. So I will be left with NH and C2H5. I am left with the NH and C2H5. So this reaction, for your convenience, what I will do, I will write it as what, I will write this one, or else this one. C2H5 and H2 can be written as C2H5 and H2. C2H5 and H2. To this one, I will write CH3COCl. I will write like in this manner. It is CH3COCl. So this group will go. This is Cl, CH3COCl. So this HCl will go. Here, HCl will go. Tell me what I am left with. C2H5NH. 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 COCH3. COCH3. Nothing but set. Both are set. So the same reaction I have done here. So this is ethanamide. There are two carbons, so it is ethanamide. Which ethanamide? N-ethyl. Ethanamide. N-ethyl. Both are set. The name of this one is N-ethyl ethanamide. N-ethyl ethanamide. Clear? N-ethyl ethanamide. See, this is ethanamide. There is an ethyl group over here. So it is N-ethyl ethanamide. Nothing but N-ethyl ethanamide. I have written different patterns so for your convenience. Clear? So let's take another example. Another easiest example so that it will be easier for you people to understand. Both alkyl groups are same this time. I am having CH3 and H2. CH3 and H2 is made to react with the Cl and let it move over this side so that it will be easier for you. Cl, CO, CH3. Clear? So this entire group will go out. This entire group will go out. So just now earlier I have done a mechanism also I have put. So now I will tell you what you will be left with. CH3 and HR. I'm left with what? CH3NH. This CH3NH attached to what? COCH3. COCH3. Clear? So again I am having ethanamide. Your name should end with ethanamide. Ethanamide is attached to a nitrogen. That nitrogen is attached to methyl. So it is N-methyl. This is N-methyl ethanamide. It is N-methyl ethanamide. Correct? It is N-methyl ethanamide. Correct? No? Similarly, I will write another example in which I will take two different, the different example. We are taking different reactants. Here I will take C2H5 or else CH3, same. I will take secondary amine this time. CH3 and CH3H plus same. COCH3, acetyl chloride, same. So this HCl will go out. So this HCl will go out. This HCl will go out. Can you please tell me what you are left with? CH3 and CH3? CH3 and CH3, and that is further attached to COCH3. That is further attached to COCH3. So what will the ideal say? Again, same I am having ethanamide. So your name again should end with what? Ethanamide. Sorry, yes, ethanamide. And this time I am having two methyl groups. So that will be my N and dimethyl. I am having what? N and dimethyl ethanamide. N and dimethyl ethanamide. Okay? N and dimethyl ethanamide. N and dimethyl ethanamide. N and dimethyl ethanamide. So this is nothing but addition of acyl group or acylation. This is my what? Acylation. Acylation of amines. Amines reacts with acyl chloride so as to give you what? Amides. Acylation. Clear? Yes or no? Similarly, if suppose I am going to add benzyl group, I have added acyl group, that is called as acylation. If I am going to add benzyl group, that will be benzylation. Simple. Yes or no? That will be my what? Benzylation. So what would be the, if suppose you want to get benzyl, what you are supposed to add, you tell me? For amine, for primary amine, you are supposed to add benzyl chloride. That's it. Benzyl chloride, for example. I'll write example. After acylation, we are discussing about what? Benzylation. Because I am adding benzyl chloride. Benzyl glycol, in fact. Benzyl glycol. That is nothing but my benzylation. That is nothing but my benzylation. Clear? Benzylation. I am having C2H5 and H2. C2H5 and H2. I will add benzyl chloride. Do you know benzyl chloride? Earlier I have written acetyl chloride. Now benzyl chloride means there will be a chlorine, there will be a CO group. This time it is attached to benzene group. That's it. It is attached to benzene. Benzene COCl is nothing but benzyl chloride. It is nothing but benzyl chloride. Yes or no? It is a benzyl chloride. C6H5 COCl you can say. NH2, one of the hydrogen. This NH2 can be written as what? NH. So this part will go. Tell me what I am left with. I am left with what? C2H5NH. C2H5H attached to COO and benzene ring. So this is the parent. This is benzamide. This is what? Benzamide. This is benzamide. So the name should end with benzamide. Which benzamide? N-ethyl benzamide. That's it. N-ethyl benzamide. N-ethyl benzamide. So addition of benzyl chloride so as to get benzamide is nothing but benzylation. Is nothing but what? Benzylation. Okay? So this is the another chemical property or addition of benzyl product, or you can say benzoylation. Clear? So this is the chemical property. Next chemical property. We'll go for a named reaction. We'll go for a named reaction over here. Named reaction. Let's go for named reaction. That is the important. Carbyl amine test. Carbyl amine reaction chloroform. Carbyl amine reaction. Please remember very important because I'm talking about reaction with chloroform. Reaction with what? Chloroform. Reaction with chloroform. So let us talk about this one. RNH2. RNH2 plus it is made to react with chloroform. CHCl3. CHCl3 in presence of alcoholic KOH. In presence of alcohol, ethanolic KOH. Ethanolic KOH. When it is made to react with this one, when primary amine, particularly primary amine, please remember, particularly what? Primary. In carbyl amine reaction, I can't take secondary amine. Only primary amines will show you what? Carbyl amine reaction. Let's see about the result I will talk about later. So RNH2 in presence of chloroform and KOH converts primary amine into what? Isocyanates. It converts this one into what? Isocyanate. And my byproducts are KCl plus H2. 3 moles. Clear? So, but primary amine is treated with chloroform in presence of ethanolic KOH. Isocyanates are formed. Isocyanates are formed. This is nothing but carbyl amine reaction. And carbyl amine reaction is shown only by what? Primary amines. Primary amines. Okay? So that is why this reaction is used as a test for primary amines. This is used as what? Test for primary amines. Because only primary amines will form isocyanates with chloroform and KOH. No other amines will show this reaction. And that is why it will be easier for us to distinguish primary amines from secondary and tertiary amines. So this is a distinguished test. It's not only carbyl amine reaction, it is also called as carbyl amine test. Carbyl amine test. This test is to detect the presence of what? Primary amines. Primary amines can be detected by using this one. If primary amine is added to chloroform in presence of ethanolic KOH, you will get a disagreeable smell. You will get what? A disagreeable smell because of formation of isocyanates. These isocyanates have disagreeable smell. Disagreeable smell. Or bad smell. You get bad smell. Bad smell. If you are getting bad smell, means there is a formation of what? Isocyanates. Isocyanates smells very bad. Okay? So unpleasant smell. Okay? Unpleasant, very bad smell. So that confirms the formation of what? Isocyanate. If you are taking a secondary amine over here or tertiary amine over here, if they are supposed to react with these, they won't react. Then it will be easier for me to identify the presence of primary amine. That is why it is called as what? Carbyl amine test. Carbyl amine test is shown only by primary amines. I will write the example over here. I am having CH3NH2 is made to react with chloroform CHCl3 in presence of KOH alcoholic. In presence of KOH alcoholic. So CH3NH2 gets converted into what? CH3NC. It gets converted into what? CH3NC. CH3NH2 primary one, chloroform, potassium hydroxide is going to give you isocyanate plus KCl plus water. 3 moles. So I am going to get methyl isocyanate. I am getting what? Methyl isocyanate. So formation of methyl isocyanide is confirmed by observing smell, by having smells. If you got disagreeable smell, means there was a primary amine in what reactant. If I am going to add a secondary amine, I won't get disagreeable smell because they won't form isocyanates. So carbyl amine test is used to detect the presence of a primary. Once again, I will explain this. Please do remember, when primary amines are made to react with chloroform in presence of alcoholic OH, a disagreeable smell is observed, which confirms the formation of isocyanates. That is called as carbyl amine reaction. So in this carbyl amine reaction is shown only by what? Primary amines. Secondary amines and tertiary amines won't react with chloroform. They won't form isocyanates. After addition of secondary and tertiary amine, I won't get disagreeable smell. So that is why this reaction helps me to distinguish primary amines from secondary and tertiary. And that is why this carbyl amine reaction is called as what? Carbyl amine test. This is called as what? Carbyl amine test. So carbyl amine test, as I said, it is used to distinguish between primary from secondary and tertiary amines. And please do remember, this text is shown only by what? Primary. And this is an example. You can take any other alkyl groups over here. Any other alkyl groups you can take and you can write the products. You are going to get different. If suppose I am going to get aniline over here, I will write that example over here. I am having NH2. So this NH2, what I will add? I will add chloroform. I will add what? KOH. I will add KOH. Chloroform and KOH. Can you please tell me what you are going to get? Yes, it gets converted into phenyl isocyanide. It gets converted into phenyl isocyanide. Phenyl isocyanide. Carbyl amine test for primary. This is also primary aromatic amine. Primary aromatic amine. Primary amines will show you what carbyl amine reaction. Carbyl amine reaction is amines are made to react with what? Chloroform in presence of KOH, so as to get isocyanates. Okay, so this is the reaction of amines with what? Chloroform. Clear? So now let us go for another important reaction. Another important reaction. A reaction with what? Nitrous acids. Let us go for reaction of amines with what? Nitrous acids. Nitrous acid. What do you mean by nitrous acid? Reaction with what? Reaction with nitrous acids. So let's talk about the reaction with nitrous acids. Reaction with nitrous acid. Nitrous acid. What is nitrous acid? HNO2. Nitrous acid. And how this nitrous acid can be prepared, you tell me first. You are supposed to take sodium nitrate and HCl. Sodium nitrate means NaNO2. Sodium nitrate. NaNO2 is made to react with what? HCl. NaCl will go out. Then what you are left with? HNO2. HNO2. This is how I will prepare nitrous acid. Right? It cannot be stored because it is unstable. That is why it has to be prepared freshly. So now what happens if suppose this is going to added to what primary amine? HNO2. If we are adding HNO2 to this compound, correct? HNO2 to this compound in presence of again a small amount of what? NaNO2 and HCl. This HNO2 is unstable. That is why it is prepared in situ. This is prepared in situ. In situ in the sense during a reaction. That's why I have mentioned NaNO2 HCl, small amount. So these guys are going to form Rn2 plus Cl minus diazonium salt. They are going to form a diazonium salt. But this alkyl diazonium salt, this alkyl diazonium salt. This alkyl diazonium salt is very least stable. It is very least stable, and that is why on hydrolysis it's reduced. It is readily converted into alcohols. It is readily converted into alcohols, and this in this manner amines will react with what? Nitrous acid. Remember amines CH3 and H2 reacts with HNO2 so as to give you what? CH3. So that you will remember. So when amine is made to react with nitrous acid, my final product is alcohol. Please do remember I am talking about alkyl amines. Only alkyl, not aryl. I am talking only about what? Alkyl amines, not aryl amines. I will tell you why. So one thing you remember, alkyl amines on treatment with what? HNO2 is going to give you CH3. For your convenience, I will make it even easier. CH3 and H2. I am having CH3 and H2. I am adding what? HNO2. So this HNO2 can be written as what? HNO2 can be written as what? OHNO is nothing but HONO. HONO is nothing but my HNO2. So what I will do is that here in this case HNO2, I will write HONO. HONO. I have written HONO. Okay, HONO is nothing but, so this part HONO. Very simple. See, I'll be left with CH3 watch. CH3 watch. CH3 watch. Plus N2 plus N2 plus H2. Plus H2. Okay? Here also same. Plus N2 plus H2. Here also same. Plus N2 plus H2. Here, remember this is an easier way for the representation of reaction of amine with what? Nitrous acid. So when alkyl amines are made to react with nitrous acid, they are going to form what? They are going to form alcohols. They are going to form alcohols. Okay? Then let us go for the last reaction. Today's last reaction. I mean, after alkyl amines, how aryl amines will react. Let's see how aryl amines will react with nitrous acid. How aryl amines will react with nitrous acid. Aryl amine. I am having it with aniline. I am having what? Aniline. So aniline is made to react with what? HNO2, nitrous acid, primary aromatic amine. Means it is prepared in situ. Instead of HNO2, what I will add? HCl and NaN. So I will add what? HCl and NaN. That is nothing but my what? HNO2. It is prepared in situ because HNO2 is unstable. So that is why. So these two will give you what? HNO2. These two will give you what? HNO2. Okay. OH, as we have written earlier, HONO. HONO is nothing but HNO2. HONO. HONO can be written in this fashion. Let HONO. After this, my primary amine is converted into N2 plus Cl plus aryl diazonium salt, and it is stable because of resonance. Earlier, alkyl diazonium salt was unstable, so as to attain stability, it used to give you what? Alcohol. So alkyl amines on reaction with nitrous acid, I used to get what? Alcohols. But aryl amines are going to give you diazonium salts. Aryl diazonium salt, benzene diazonium salt. Clear? Benzene diazonium salt. it won't further undergo any reaction and gives you what phenol. You can't write phenol over here. Don't expect phenol because it is stable. Earlier in this intermediate state, the alkyl diazonium salt was unstable. That is why I used to get what alcohol. But amine will give you what only diazonium salt. This is very important as far as your competitive level exams are also concerned. They may ask you. So alkyl amines on treatment with HNO, they are going to give you what? Alcohol. Similarly, aryl amines, NH2, aryl amines on treatment with HNO, they are going to give N2 plus X minus. That is N plus. So this is the difference. Amine, alkyl amine, aryl amine. Alkyl amine, alcohol, aryl amine, benzene diazonium salt. These also form benzene diazonium salt, but those are unstable. And that is why at the end I am going to get alcohol. So this is how amines, primary amines you can say, will react with what? Nitrous acid. Or make it react with what? Nitrous acid. Clear? Yes, sir. So this is the reaction of what? Amines with nitrous acid. Okay. So we have come across these many things in today's session. We have started with what? Reaction of acids. Before that, we have started with what? Basic nature and aqueous solution. Clear? So all these things we have written, and then so rest. We are left with some more chemical properties too, and will be discussed in what? Next class. So rest of things will be discussed in next class. Thank you.
Great. But